Hi everyone, this is Ashwin here. In this video we're going to see about how to detect motion using OpenCV. So whenever we are using CCTV footage surveillance or any kind of surveillance camera, they usually have a motion detection system. So there are advanced motion detection technologies which includes tracking of objects, which we will cover in the later videos, but for this one this will be like a basic motion detection tutorial which you can use to detect motions for a static camera. So this does not work if the camera is moving all over the places and you want to detect motion in that. So this works if there is a static camera, similar to how CCTV camera works. We can detect motions pretty good. Okay, first let's import the modules. So we have to import OpenCV, which is very important for this, and then NumPy, and we will also use matplotlib.pyplot as plot, and import amutils and import time. Let's run this. Okay, amutils is not there, so I'll just install it quickly. So if you face any issues, so you just check what is the full package name and install it using this pip install, and when you run it, it should not show any errors. After this we have to define some functions in order to view the image and how we can detect motion in an image. So def load and pre-process. I will pass the image path. So this function we will also use it for detecting motions in a video. So image equals cv2 dot imread, pass the image path, then we will resize the image cv2 dot resize, or else it will be very big for the video which I am using. I'm going to change it into a 720 pixel image. So 1280 cross 720, you can change whichever resolution suits for you, and we will convert those image to a grayscale. So cv2 dot convert color, pass the image, and cv2 dot color underscore bgr to gray. Okay, and I will return the image and the gray image. Why we are using grayscale is the detecting of motions will be very easy if we have a single dimension. Before we have a 3 dimension which is BGR, we can also change it to RGB, but if we have grayscale means we only have single dimension, and it will be easier for doing the processing. So this is for loading and pre-processing the image. Load and pre-process the image, and then we will subtract the images. Subtract images. So this is the crucial function where we do this motion detection. So def subtract images of image 1 and image 2. Here image 1 will be like a static image or a rest image, and image 2 will be the new image which we will find what is changed from the static image. So that's why we are using this subtraction. So diff equals cv2 dot absolute difference of image 1 and image 2. Then we will use a threshold. Thresh equals cv2 dot threshold of diff, and you have to define until which pixel you want to define a threshold. I am going to fix it for 85, and the maximum pixel value is 255. If you have a normalized image, you can have this as like 1, and you can set this as like 0.2 or 0.1, depends on like the type of image you are using. Currently we have a normal image which will have the pixels in the range of 0 to 255, so we will use 255 and cv2 dot thresh binary, and there are other thresholding methods that you can use, but for now I'm just going to stick with binary, and if it's above the threshold it will just have the threshold value or the pixel value as 1, and if it's below it means it will set it as 0. Now return the difference and the threshold. Now we can plot these images and see how different the images are. Image path 1 equals, I have a static image. If you are using a video, you can use the first frame of the video as a static, or you can just take a screenshot of it and use that as a static image, which is the rest image, and then a test image which I'm going to use. We will load the images, load and pre-process image path 1. You do the same again, just change this to 2. Okay, now subtract the images, diff and threshold we will get if we use that function. Subtract images of, you have to pass the grayscale image for processing, so grayscale image of 1 and grayscale image of 2. Now we have to plot the images. Plot the images. So plot dot figure of fixed size. We'll define this as 15, 10. We can adjust the size later as well. Then plot dot subplot. As we have to display 3 images, I'm going for a subplot here. So 1 to 3, like 1 row and 3 columns, and this will be the first column. Plot dot title, I will say static image, and plot dot imshow. We have to convert this to RGB from the BGR format. So cv2 dot convert color of image 1, which is the static image, cv2 dot color underscore BGR to RGB, and then plot dot axis off. So this will just remove the additional axis we don't need for displaying the images. Now we just gonna do the same for another 2 columns. Plot dot subplot 1, 3, and this will be 2. Plot dot title, this will be the difference, and plot dot imshow, which is the diff, and cmap is gray as it's a grayscale image, and here also we will remove the axis. And lastly we have the third column, and this is the threshold image or threshold difference. Now plot dot imshow thresh and plot dot axis off. Let's run this. I think we can use plot dot show to remove those lines, and we missed this cmap equals gray. Now you can see this is the static image and this is the difference. I think I forgot to place the test image as well. I should add it. Maybe we can have 2 comma 2, and this can be 3, this can be 4. I'll just copy those values to replicate this, and here this will be 2, and this is the test image 2. Let's run this once. Okay, now this is much clear. I think we can decrease the height a little bit. Okay, I think 15 and 7 should be fine. Okay, this is good. So this is the static image or the rest image, and this is the test image which have like additional car and the truck or bus. You can see the difference based on the threshold. The differencing will change. So this is the car and this is the van, and if you do this threshold difference, it will change this dilated values to like 1. If you change the threshold value, let's say 50, so this is how the images look like, and you can see some minute images were there. This additional dots were there. It was due to moving of these trees. We will see how to ignore this and only capture the majority of the pixels which have those difference. So this is the exploratory analysis of using an image. Further, we can have like a bounding box of where the difference is occurring. So before that, we have to like dilate the image. So dilate equals cv2 dot dilate of thresh none and iterations equals 2. Let's plot this dilated image. It would be much more sense to have a meaningful variable name instead of having this as dilate. Run this. We could have the axis of and plot dot show. So this is good. It just highlighted or connected the dots, so the images are much more clear. And as I said, these will come up because of the movements in the leaves or the grass. Okay, now this is good. Let's get the counters for this to have the bounding boxes. So cons equals cv2 dot find counters dilated image dot copy cv2 dot external and cv2 dot chain approx simple, and then imutils dot grab counters. Sometimes due to the different version of OpenCV or different methods, the counters will be different. So with the help of imutils, we will normalize the counters here and we can display it. You can see all these are counters, which is the pixel coordinates which is highlighted. So you can see these are some big counters and some of them are very small. So based on the size or the area, we will only display the counters whichever have the biggest area. Okay, now this is done. I will maybe comment this part because this is a big one, and when you see the full notebook, it will be very big. So I'll comment this one, and we will loop over the counters and display it in the image. Iterate the counters for C in cons if cv2 dot counter sorry, okay, I'm making some mistakes. Contours and contour area of C is less than 700. Again, you have to experiment it based on the resolution of the image. I will just skip those counter. If else, I will get the coordinates, get the bounding box coordinates. So x and y, width and height equals cv2 dot bounding rectangle of C, then cv2 dot rectangle of, pass the test image that we have, coordinates which is x and y, and starting coordinates and the ending coordinates. So x plus width and y plus height, then the color 0 to 55 and 0, and the thickness. Then we will have a title. I will treat it as test image. I will pass it cv2 dot wait key of 5000. So the image will be shown for 5 seconds, and cv2 dot destroy all windows. After 5 seconds it will destroy the window. Now let's run this. Okay, this is IM show. Run this. Now you can see the bounding box is displayed here, and you could clearly see, let me increase this to 10 seconds. You can clearly see not all the things are covered, only the bounding boxes for the van and car is covered. So that's pretty accurate for us. Now we are going to do the same for the frames in the video. I have a test video for this, which is a surveillance video. If you want to do it in real time, have like a room in rest motion, and you want to identify if some persons or some objects are being moved, you can use this to identify the motions in real time. Okay, now I have a video path, or test in real time or video. Okay, now video path, I have a test mp4, and then video cap equals cv2 dot video capture of the video path. If you want to capture it from a webcam, you can also do that. Video cap equals cv2 dot video capture of 0. This will capture from webcam. I will comment this for now. Then I will have a static frame equals none. So either you can directly initialize the frame here, or you can also initialize it in the loop. So while true, success comma image equals video cap dot read. So this will read frame by frame, and I think the current is FPS is around 18 FPS, I think, for this video, as this is a CCTV footage. They usually capture less frames compared to the regular videos which you would find. If not success, then break. That means if the video is completed and if there is no further image to read, we will break from the loop. Then image equals resize. We already done the resizing before. We are doing the same here. 1280 cross 720 and then convert it to grayscale image. I think we could use that preprocess function here. Image, gray image, load and preprocess. Okay, I think we cannot do that because we are passing the image path here. If you pass the image, you could do that. So you just copy and paste it here. Or you can have some additional arguments and handle both of the cases. That would be much better. If static frame is none, so only it is none, we will update it. So static frame equals gray image. That means we are taking the first frame, which is the wrist image, as a static frame, and then continue. So we will process the next image. And then if the static frame is already set, means we will go for the differencing and thresholding part. So subtract images of static frame and the image, or else we will have this as a frame. So we are processing each frame. It would be better to have a common format. Okay, now we got the differencing and threshold. After that we have to do the dilation. So dilated image, paste this. Again we will grab all the counters here. Get contours and get the subtracted frames. After this we will highlight only the contours which have a minimum of 700 area. So we will just copy this, include the comment so that I don't have to retype it again. So this will highlight the frame, which is this original frame. We don't want to see the grayscale image as a video, so we will just use the original frame. For only processing, we will use the grayscale frame. And then, so this will be gray frame. Then display it cv2.imshow motion detection, comma, the frame, then exit if any key is pressed. So if cv2 wait key of 1, and we are going to just do inversion so that it will capture any key that is pressed, not equal to 255, then break, and I will have time.sleep to make it look that the frames are real, because it has 18 fps. To make it like 25 fps, I'm just sleep the program for 0.1 second. And finally video cap.release, we will release the video once all the process is done, then destroy all the windows. Okay, I think this looks good. Let's run this. Now you can see the motion is clearly detected for the car, and additional motions were being detected because this trees are moving because of the air. You can clearly see that. So all the minute motions have been detected because of the larger area of the tree motion, that's why it just captured that as well. We could handle that to avoid counters with small boxes, so we can definitely do that, but I will leave that as like for the advanced project, which we will cover later. But this covers everything, and at least the motions are clearly detecting for the cars that are moving in the video. And that's pretty much it, guys. If you have any queries about the video, please leave a comment below and I will definitely help you. And other than that, if you like this video, hit the like button and don't forget to subscribe the channel for more videos.